Hi, my name is Stas.
Hi, my name is Illya, and we are so glad to join you on Azure Back to School community event. We will share our experience and be happy to learn from you.
And today we will be talking about distributed application runtime from Microsoft.
We will tell about our experience and the obstacles we have conquered.
So, let's go?
Let's go.
Hi, my name is Illya Solovyov. I'm a developer with more than 3 years of commercial experience and quite a few non-commercial projects and attempts to solve my everyday problems with coding. I have joined Sigma Software as a student, and even though I'm no longer in a university, studying is still a large part of my day-to-day experience. After starting as a .NET developer working on a 10-year-old legacy application, I've been thrown to multiple sides of IT, from embedded and mobile to cloud solutions, with more than 30 microservices running. I wouldn't have survived without numerous guides by numerous people, so it's only fair I try and share my knowledge with others too. The technology we're about to cover is pretty new topic for me too, so this presentation has been a good reason for me to try out something new and fun. Hope you enjoy it. First, let's talk about what DAPR can do for you. Let's find out if DAPR is a good fit for your application. As the sidecar is communicated with via HTTP or gRPC, there's no limitations on languages, frameworks, cloud vendors, and so on. Additionally, there are multiple extensions to better integrate DAPR with existing solutions, such as, for example, Azure Function Extension. In other words, if you are building microservices or serverless, DAPR might be the right tool for you. The main question you'll have when working with DAPR is, which building block will help me with my current task? DAPR solves multiple questions you might have, such as state management, PubSub, resource binding, secrets, and so on. Of course, your cloud vendor most likely provides most of this behavior, but in a platform-dependent way. We don't usually change clouds mid-development, of course, but utilizing DAPR means you'll be ready for this scenario, and for the smaller changes too. One of the most important differences between DAPR and a service mesh solution is how they treat service-to-service communication. DAPR uses a name resolution component, meaning you'll be working with namespaces instead of, for example, IP ranges or URLs. This is one of the examples of DAPR being developer-oriented and focusing on the abstractions instead of the specifics. If you are like me and you have never heard of gRPC before, let's take a few minutes and talk about it. gRPC is a communication scheme based on HTTP2 protocol. It is used in applications where performance is critical, as all gRPC messages are serialized using protobuf, resulting in small message payloads. There are numerous additional features like bidirectional streaming and strict communication contracts. You may ask, why don't we all use gRPC then? One of the problems with this approach would be the fact that gRPC is not supported by browsers, and its messages are not human readable. Additionally, a contract is required for every API, while for the regular HTTP API approach, the contract is optional. This affects ease of use for smaller applications, which may be the reason why we are not completely shifted to gRPC. Now, let's talk about what made the developers at Microsoft come up with DAPR. As you all know, microservices are considered the go-to solution for building a modern, decoupled application. The benefits are clear: independent development and publishing of each service, better scalability, and so on. But what about the price for choosing this approach? You have to write infrastructure code, you have to detail every required service interaction, you have constant code duplication for the basic needs such as utilizing secrets, publishing and subscribing to events, failure tolerance, need for manual rerouting, and so on. Sometimes the everyday cons start to outweigh theoretical pros. Service mesh is a proposed solution to the problems listed before. All of the network communication code is moved into sidecars, running along our services. The actual service now only carries the business logic and a generic approach to communicate with the sidecar. Nothing less, nothing more. For example, if you need to change how request-retry flow should work, you only update the sidecar. You no longer need to update every single service. Service meshes usually provide a ton of useful features out of the box. Developers no longer need to wrap their heads around, for example, manually collecting metrics either through code or via their cloud vendors. There's no need to introduce custom solutions for encryption, for failure tolerance. Service meshes are supposed to take care of all that and much more. So, this brings us to our final question. Why DAPR? An important thing to understand is DAPR is not a replacement for service mesh. It's a separate tool that shares a lot of the ideas but has a different use case. Unlike service mesh, which is a tool for system operators and is focused on network communication, DAPR is a set of building blocks and common solutions for the developer. It is supposed to help you follow best practices in development and cover common scenarios such as, for example, secret storage and retrieval, PubSub behavior, state management, and so on. DAPR can be run together with service mesh in separate sidecars if you want to get the best of both worlds. But for now, let's focus on DAPR and see if it's enough to solve most, if not all, of your problems.
Hi, my name is Stas. I'm working as software architect in Sigma Software. Still writing code, still having fun doing interesting projects from scratch and refactoring them to the new technologies. I have around 17 years in IT. I'm Microsoft Azure Most Valuable Professional since 2020, also certified cloud architect and co-organizer of Odessa.NET user group. This is our first hybrid talk with Illya, so I hope you will enjoy it. Now let's talk about interchangeable components of DAPR, how easy to switch them and how easy to lift your application between platforms and clouds and on-premise deployments. I can say that this is the most exciting feature of DAPR because this allows for one of my projects to easily switch on-premise deployment to cloud deployment and vice versa. So for cloud we're using Azure Service Bus, and for on-premise we're using PubSub broker such as and for on-premise we're using PubSub brokers and for on-premises we're using Lebenenko broker, which is still in preview but actually is working very well. And this allows to write code for the single project that can be deployed anywhere and do not care about dependencies and do not inject dependency SDK into the project code and don't care about upgrading of these SDK versions and patching them to avoid issues. There are actually two generally available message brokers. It's Azure Service Bus and Redis Streams. But as I mentioned before, we're using Lebenenko for on-premises deployments. Regarding the state store's general availability, there are more storages available and even more on the way for different clouds and for different on-premise deployments. They even have Microsoft SQL Server in preview as a state store. But while we have a lot of components on the way, there are also issues. There are limited support of the features for these underlying message brokers and storages by DAPR. But this is only reasonable because DAPR intends to support only basic functionality for publisher-subscriber component and basic key value stores. But otherwise they collecting a lot of feedback and trying to implement additional features and additional feedback changes to these modular components. As example, there is no message time to live for Azure Service Bus or Kafka topic configuration available from DAPR, so there is no way for you to configure this stuff. But development team already working on this. There is also no .letter queue configuration, and there is also no convenient settings to set max batch size because many brokers use it. So batches of messages will be delivered in single loop, and this results in a lot of traffic going back and forth inside DAPR sidecars because messages are not treated in batch. Now let's talk about DAPR for developers. We are using it from the C# code, obviously. And there are different ways to communicate with your services. One of them is to use SDK via NuGet package and just create DAPR client and connect to the needed services via service name and service method. There is also alternative way to invoke your service via HTTP client, so you will avoid injection of DAPR SDK into your application. But this is a little bit more complex way because you need to use direct URLs and you need to have them in some kind of a configuration because this way SDK will not use service discovery to connect them with each other. There is also alternative way to connect to the DAPR sidecars. You can do this with gRPC protocol, and for this you need to download the protobuf files from the DAPR framework. But this way you will also avoid usage of the SDK, and you will need to inject gRPC NuGet for this and use impacted protobuf files in your solution. This is also a viable way if your language doesn't support it by DAPR SDK. But for .NET developers, usage of the NuGet package with DAPR SDK is the best way possible because it's seamless experience and you don't need to do manual discovery for this. But alternative ways is super useful if you have some kind of a legacy application, let's say classical .NET framework that needs to be integrated with a new one. You can containerize them, put them to Kubernetes, and just call your DAPR service invocations via HTTP protocol. At least it was we tried to use and it was a success. And now let's talk about DAPR statestore and its consistency models. The main goal that DAPR aims to solve for you is distributed consistency and data consistency that can be complicated to implement by yourself. DAPR allows you to plug in different stores, but the main benefit is that you can attach additional metadata to the state operation and set your concurrency requirements and consistency requirements. DAPR using optimistic concurrency control with entity tag. So this way you can be sure that only operation with the current tag value can result in update or delete of the current state. But usage of entity tags will effectively switch your concurrency settings to the first right win pattern instead of the last right win when you don't using entity tags. And about consistency. Strong consistency and eventual. What's the difference? With strong consistency settings, DAPR will wait for all replicas of designated quorums to acknowledge before it acknowledges a write request. And this might result in significant slowdown of your application. So when eventual consistency is used, DAPR returns as soon as the write request is accepted by any underlying data store. One important note here that actor state component is using only transactional data stores. And this introduces additional limits onto your solution. And additional limits means that you can use Azure Cosmos DB or Redis, but you cannot use the Azure Blob Storage. So the main learning from working with a state store is that default configuration for consistency is optimal. And if you need to work with actors, you should work with transaction state storage. And if you want to use your old relational database such as Azure SQL, you should use it outside of the DAPR store component. And now let's talk about self-hosted mode for DAPR, which is super important from my perspective if you intend to connect your old applications with new DAPR services or maybe even Azure functions. So if you have an old virtual machine, you can install DAPR there and run it as service, but you will have only service invocation building block. But this way you can connect with your legacy application via direct HTTP calls, as I mentioned on the previous slide, and you configure server, and you can even split your old application into the two services, let's say, and deploy them to the IIS. This way you will have all manual controls over your environment, so you need to set up Redis for your DAPR state store or PubSub components. You can install RabbitMQ on different machines and just configure your DAPR to use them. This way you will avoid usage of the Docker of Kubernetes cluster on premises, and you can run your application on simple virtual machines. And this is also a scenario when you have predictable load on your application and just want to use service invocation and maybe PubSub functionality for your application on-prem, and don't need any orchestration because load is predictable, as I mentioned, and you don't want to do any changes to your code, because applications, when you have a heavy load, they deploy it in some cloud on Kubernetes cluster, but applications with fewer requests can be run on-prem and integrated with cloud if needed. We will have a demo soon, but before the demo, let's talk briefly about direction of the DAPR evolution. There are several frameworks that can be used along the DAPR. It's framework TIE, it's framework KEDA. There is a lot of articles on how to use them together and what problem they are solving. But from my perspective, there is a chance that all these frameworks will be integrated in coming years, because they simplify and provide event-driven scale for microservices, and it will be something like a serverless for containers. So it will be like a DAPR as a framework for abstraction for serverless container orchestration or something like this. This is kind of what I see in the future. It's not proven by anything because there is no information about this development, but it's my idea where everyone is moving right now. So it will be a cross-platform framework to port your Docker containers, so they will be scalable and they will be agnostic of the storage, so you can easily lift the applications from AWS to Azure and vice versa if needed. And infrastructure will become a developer responsibility, because this is kind of main feature. It allows you to configure some network restrictions in your code, not in your code, but in DAPR configuration, how services can call each other and will they have access to actually do this. I see DAPR as a framework that provides abstraction over Kubernetes, and in coming years, Kubernetes will be something abstract. And now let's proceed to the most interesting part, deployment of the application with DAPR and communication between services and switch between PubSub brokers. So let's start with a short demo. Maybe it will not be too short, but let's try. So first we have my GitHub and repository DAPR in action. It's repository for the workshop of the Net Framework Days conference. So it would be good to reuse it for our purposes, and also you can visit this repository and copy description, data and solution and deploy it to Azure and try DAPR for yourself. So let's begin with copying of this Azure CLI code. Actually, we can do this like this. Just like this, and paste it into the Azure Bash console. Let's open it again from here. Let's open. Actually, I already have 2 copies of this infrastructure deployed to speed up the demo, but we will stick with this. So you need just to copy paste, and entire infrastructure will be created for you. So the next step, we will use repository 2 services extra start. It's the sample with the PubSub that is using RabbitMQ, and later on I will commit the results of this demo to this repository, and it will be a PubSub sample for the Azure Service Bus. Yes. So let's switch to our solution. It's basically 2 services connected via PubSub. It's paper delivery and paper orders. It's using DAPR SDK, DAPR ASP.NET Core 1.3. Order controller is handling EDI orders and saving initial order to the database, and then this order sent via PubSub to delivery service. To the method create delivery. Create delivery annotated with DAPR attributes, topic PubSub name PubSub, and name of the topic. It's actually API controller, nothing fancy here, and it's also working with a separate database and saving data and returning object result in case of the success. I have 2 manifests for the T-Paper delivery service. All secrets are stated explicitly here because it's easier to handle this way demo, and it's easier to comprehend the workshop step by step. Also, I have a component, RabbitMQ component for the Kubernetes cluster, and also I have a PubSub component for the RabbitMQ for my DAPR services. So you can see here is the scopes of my services. And also I have PubSub component, and also I have a PubSub component required for service bus. Obviously it's a fake service bus connection string, but you can fetch it later on from repository and use it at will. So while infrastructure are deploying here, as you can see. Azure Kubernetes cluster is creating, but we already have these components right here. Actually, what I forgot is to toggle these masks, but it's not that important. And now we can switch to the small helpful document that I prepared from the flow of my workshop. As you can see, there are a lot of steps and a lot of versions of repositories here, so you can just follow it through. But at the moment we need to build our containers. Basically it's configuration docker compose and release, and you need only to hit build. Now build is started. Now all the containers are built successfully. Now we need to double check that container versions is in proper order. But for this, we need to do the login to the newly created container registry from the command line. I already logged in, so I'm just pasting in commands from this notepad. But actually, these commands are duplication from the workshop repository. Here you can have it. So you must do the AZ login, then show your subscription, then apply following commands like here, it's the copy. Let's observe results. So we have a service Kubernetes and internal IP addresses, fine. Then we will do DAPR init. Then we will do DAPR init command. This will initialize DAPR into the cluster. I'm doing this from the command line because of the convenience, but actually you should do this via Helm charts. So as you can see, our deployment went successfully. And we will double check this with DAPR status. But there is one important thing that we need to do. As you can see, DAPR operator, placement, service center, sidecar, everything is working. But as you can see, infrastructure already deployed and everything seems to be fine. But now we need to open this group MC Network Days cluster. It's created with network components and virtual machine scale sets. Open virtual network, open service endpoints, and add new service endpoints. Select the AKS subnet and select Microsoft SQL. Yes, and select subnet again. While this is adding, we should open DAPR data, open SQL Server, open show firewall settings, set allow Azure services to connect, and add existing virtual network. And now we can see this network. It's located in this group MC Network Days cluster not Europe, and hit OK. Hit OK. It will be created soon. Integration will be created soon. And when it will be created, we should click to save. Okay, we have it now. And we click in save. Now let's switch back. Now we have connectivity between our cluster and Kubernetes, between our Kubernetes cluster and SQL Server, because we're using in this solution migrations and etc. Now we need to proceed with tagging the images and Now we will proceed with docker tag command, double checking images, docker push to the private registry, and then kubectl apply for particular service manifest. So let's copy paste this. Okay. kubectl get all to check status. Container creating. Let's proceed with the second one. Paper delivery service already running, and second one is still in progress. Let's check. Two of them are running now. Of course, there might be issues if we use it wrong secrets here. It's open at secret, so I will drop this environment after a few minutes after recording this demo. But let's check our PubSub RabbitMQ configuration and RabbitMQ configuration again. We need to deploy RabbitMQ and PubSub component. Actually, one important thing is to notice these external IP addresses. Cluster is open at, or both services are open at now, so we can call them at will. Well, and as we can see, nothing is working because when I'm calling my endpoint on Kubernetes, everything is failed. But what I actually missed this time is I mismatched the flow. So I have this exception, DAPR endpoint indicated a failure, no PubSub is configured. This basically because I pushed containers earlier than a PubSub and deployed PubSub components after deployment of containers. So now we need to change, we need to rebuild containers, make it version 2. Make it version 2. Let's do this like this, and change manifest of the paper order service. Change manifest to the version 2. Don't forget to save it. And here we saving this. Actually, what I'm using to understand this feature is following two commands. First command is to kubectl logs name of the pod. So name of the pod is tpaper orders here, and I can search the DAPR logs with DAPRD command or service logs with tpaper orders. So let's hit DAPRD, and as you might see, there is no PubSub configured error at the moment in this sidecar. So we're proceeding with changing containers to the V2. Okay, here we changed everything as well. Let's redeploy them. I will mark existing containers with V2. So let's copy paste. Let's double check again. Yes, almost there. And let's try to execute our endpoint. And as we can see, everything is working, and accepted message with new EDI ID is working. Here is the order controller, and here is the output of the entry created in the database. So the next step would be to deploy PubSub component with service bus. I mean, not deploy, but switch it from RabbitMQ to service bus. But you can find this code in my repository, DAPR in action on my GitHub. And if you have any issues with this workshop or this talk, you can contact me or Illya. And I think this is it for the demo.
That's it for us. We hope you have enjoyed our presentation.
Thanks for watching our video, and I hope to see you next time in other videos, in other community events. Cheers!
Cheers!